In the previous tutorial, we looked at how to take a massing model and turn it into a planar model that could be used for fabrication. In this tutorial, we will look at how to take that planar model and now turn it into an exploded axonometric. There is a tutorial already on the Miro board that describes how to create a basic axonometric within Rhino. However, it doesn't really go over the process to do it in the exploded type of drawing. So the only difference in the model from last tutorial was that I added a little bit of information here to basically just clean up the model a little bit. So this part of it will go into the sort of digital craft portion of the grading, where if we think about actually constructing a model, we don't really want this blue plane to come up to an edge here. We want it to actually come and the red surface come underneath it to allow us to have something to actually glue to. So I've added a little bit of information there. I covered this in the last tutorial as far as how to actually do this, but I've gone through and actually finished the model here. So I'm going to now work on the exploded axonometric portion. So the first thing we're going to do is copy our model over so that we have one model that's just our massing. We can go ahead and delete the site boundary for now. And then we have one model that's our planar model, and then we have one model that's going to be our exploded axonometric model. So the first thing we need to do is take just the pieces apart of this. So I like here using the gumball tool. So if you don't have this X, Y, and Z options here, go down to the bottom of your screen and select gumball, and that will allow you to move things vertically, horizontally in the X and Y direction and the Z direction. So here we're just pulling the pieces apart so that they're separate. Don't worry about how far they actually are from one another for now. We can always move them a little bit more later. I'm just moving out in the direction perpendicular to the face of them for now. And now we're going to think about how we're going to construct this axonometric. So if we think about the basics of an axonometric, if we take our plan, the first thing we're going to do is rotate that plan, and then we're going to be drawing up from it. So we need to decide which portion of this we want to be the front of our model. So we look at the front here, and if we were to rotate 45 degrees in this direction, this would be the front. If we rotate 45 degrees in this direction, that would be the front. And then we can also look at back views and things like that. So I'm going to go ahead and take it from this view. You can take it from whichever view works best for your model. In this case, I think looking up the hill at my model this direction works the best. So we're going to go into my top view, and you can either use this part of the gumball or we can just do a simple rotate. And then you're going to decide basically whether you're rotating in this direction or whether you're rotating in this direction. Keep in mind that this direction would be a positive rotation. This direction would be a negative rotation. So I'm going to rotate negative 45. Whichever direction you choose, you should be using a 45 degree increment, so it should not be something like 60 or 30. Those would reveal different kinds of drawings than what we're working on here. I'm going to reorganize these pieces a little bit, so we can just grab these pieces and move them around now. They're not really relating to each other, so as long as we're moving them as a group, we should be fine. Now we're going to look at doing the shear command. So this is something that we worked on in other axonometrics. So if we highlight everything in our top view, we're going to type shear. And then I don't like to try to click a point on the actual model. I'll click over here, and then either holding shift to make it orthographic or choosing the ortho tab at the bottom. We're going to go off to the right and click again. Then we're going to type 45 and click enter. And then if we look in our front view, we can see that we have these all in axonometric view now. So you can see that we have pieces that are actually overlapping each other. So for now, I'm just going to make sure that nothing is overlapping with another piece. So that's really important for the next step. So we're just going to go ahead and drag these out. We can move this piece up. They can be pretty far from each other. It doesn't really matter for now, as long as they remain in the same orientation. Okay, so we're going to do something like that. So now we're going to highlight everything that we just did the rotate on and the shear, and we're going to do a make 2D. So a couple of options here that I would recommend doing. You can do either view or C-plane. The main difference is C-plane will keep your drawing in front view, whereas view will actually bring it into the top viewport. I'm going to leave it in C-plane for now. Object properties, the option that I go to most often here is going to be maintain source layers. So what this is going to do is if my red is layer 1 and my blue is layer 2, it will make a new layer underneath our make 2D category that will have a layer 1 and a layer 2 so that I can really easily turn these on and off. So I would select that one for now. And then we're going to add hidden lines to this Make 2D. You may or may not use them, but I think they're really helpful in this case, so that we can actually keep them in there to see basically a wireframe of the entire model. Again, if you want to get rid of them later, it's totally fine, but if we need to get them back later, it's really difficult. So I like to always have them, and then if you want to turn them off, you always can. And by doing this maintain source layers, all of those hidden lines are going to be on their own layers, so they should be really easy to turn on and off. So we'll go ahead and click OK here. You're going to see the generation of all of my layers here, and I'm going to just drag off those that I just made 2D. So you can see that I have all of my blue on one layer, all of my red on another, black on another, and then again I have my, these are actually on individual layers also for my hidden lines. So I have a lot of control here. I would always err on the side of more layers than less layers, so that you make sure that you have everything that you need. So we're going to do a couple of groups for now. So I'm going to group this together. I'm going to group this together. And then I'm going to go in and just group each of these pieces individually together so that we can move them really easily. Whoops. And make sure that you don't grab parts of other ones. And the grouping won't affect what layer that everything is. Just make sure that your layers are on when you're moving these around. So what I like to do for the sake of my my model is the first thing I'm going to do is I want to start with the middle of my drawing being my actual massing model. So I'm going to leave this as a massing model, and then I'm going to start adding information and exploding out from that. So if I move this, I know from how I constructed this that I can actually just grab from that corner, and I can move that all the way over there. And now we're actually just going to hide the default layer one, so that's going to be our original massing model, so that we can do a little bit of work on the axonometric. So you can see that I've already started a couple of different versions of this up here, but we're going to go through the process of how you would now make this into an exploded type of drawing. So a couple of rules first with axos. So what we want to do is we want to make sure that everything is either a vertical line or it's going to be at a 45. So what we want to do here is rotate this, and then we can mirror it. So everything that I'm drawing is either going to go off in a 45 in this direction, a 45 in that direction, or a vertical line here. So you can be a little bit creative here. So we don't necessarily just need to explode, say, this wall out in that direction. We could explode it out, and then we could move it up if we wanted to. So there's a couple of different options here. It doesn't have to just be a straight extrusion, straight explosion. So if we look at a couple of examples to talk that through, we have an example like this from a firm called The Very Many. So they're exploding everything out in 45. It looks like they're not working at a 45-degree axo here, but they're exploding it all out at the same angle in this direction and at an opposite angle in this direction. But then they're using a sort of a convention for their labeling that actually uses vertical lines, and in conjunction with basically this direction and that direction. So here we have a direction coming down like that and then back up to create our labels. So the convention that they're using here is that every single line is either a vertical line, it's one of this direction, or one of that direction. Here what we're looking at is a more radial type of explosion, so this is a little bit different. You would only use this if you're really doing something that's already circular. And then looking into other kinds, here we have a more vertical where you're exploding off in floors. Here is more of a perspective type of explosion, so we won't really be getting into this, but I like some of the graphics here. And then again, vertical. So you can see that they're using the same sort of principles that we're describing here. It should be a really simple type of drawing. This creates a nice little rule set for you here where you can really only draw in those directions. So from here, what we can do is we can start to organize our pieces. So what we're looking at here is we have two volumes here, and I have two different options. One would be, you can see here where I actually leave those two volumes together, and then we start exploding off of the top of that. Another would be that we can actually explode, so we have one volume, and then we have our massing model ghost here, and then we pull the second volume up as a whole volume, and then we sort of do two different exploded drawings sort of on top of each other. So there's a couple of different options there. You can also drag one volume out, and you can then start to explode that up and out. There's a bunch of different things you can do here compositionally to make sure that you're actually doing something that's going to do justice to the final drawing. So in my opinion, something like this gets really messy and really confusing, whereas this actually breaks down the modules and begins to understand what your floor, your four walls, and your roof looks like for each module, while still gaining an understanding of what the whole sort of looks like. So this takes a little bit of experimentation. It's probably not something that you're going to nail the first time, and that's totally fine. So here, let's take a look at, if we just copy this out, I'm going to just act like I'm doing two different, both of the different volumes here. So what I'm going to do is I'll just realign this really quick, and then we're going to do a move, and we're just going to look at moving this off at a 45. So you can move that off by a certain amount, or if we click here, you can actually start typing numbers here. So 20 isn't long enough, 50 isn't long enough, 100 looks pretty good, so we can have something like that. And then we can start to draw our actual explosion lines in here. So I have a layer that I've already called explosion. So then you can start actually pulling lines here that call out where you're actually pulling this model to. And then what we're going to want to do is we're going to want to start actually putting the pieces back onto this. So here I have the floor for my first volume, so I'm going to do a move, and I can reorient that. And now because I have a couple of different options here, I could slide this out that direction, I could slide it out that direction, but here I'm going to look at doing just a move. So I'll just move that vertically along that line. And now I'm going to reconnect back to my model using some guidelines here. So these will become eventually dotted lines or very light colored lines when you go to print this. So that shows that that piece was actually pulled down. Again, depending on how much of a wireframe you're doing here, you could actually get into doing something like that where you're pulling off all four corners. I don't think it's totally necessary to do all of the corners of all of your pieces. But that's something that I'll leave mostly up to you guys. Here we can go ahead and take the roof. So what we're doing here is we're just basically reassembling this model with its individual pieces. And the reason that we needed them to be individual pieces was so that we can move them around at will here without having to, you can imagine if we took this piece off of here, we could do it, but it would require a lot more trimming and a lot more getting rid of lines that are in the background. So I like doing it this way. Where you have basically a working model here that's all of your different pieces, and then you can really easily realign to that. So again, here we'll pull some explosion lines up. And then we have a couple of walls that we need to put on, so we'll go ahead and take our first wall. Now this one, what I would probably do is I would do a move, and then we'll go off of our 45, and let's see what 20 looks like. So 20 looks like that. Compositionally, I think maybe we want it to sit a little bit more outside of this. So what we can do is look at something like 50, and then compositionally that starts to look a little bit better, where it actually looks like this wall might sit on the outside of that. So we'll grab a line here, and this will be our explosion line. So it'll come down like that. It'll come to that corner. And then you can actually start linking these back to each other. So if we think about the way that this would actually align to this piece, you could start to think about a way of calling out that this is the sort of point. So that's the point where that starts to, where that actually intersects. So if we trim that out, we can start doing things here where we call out that this point, let's see, if we copy a line here, and then we copy this line, and then we do an extend. So you can see how we can also start to create relationships like this where maybe the style of this line, and maybe we have to split this here. So if we do a split, so maybe what we would look at is making like this line a different color or something, since this is more of a diagram of how those pieces actually align. This isn't a totally necessary step to an exploded axo, but it can start to add a lot of information as to how you're thinking of aligning different pieces. Another thing we could look at doing would be, let's say we were to trace the bottom portion of this. Whoops. So we have a curve there. And then if we look at actually moving that, you can create a sort of ghosted line here, and then you could show how that then relates to this piece. So you can show that that bottom of that piece actually starts to align there. So there's a lot of different options you can do for showing different alignments within the axo. It doesn't just have to be these simple explosion lines. And then you can get into actually what you would be showing here. So maybe for this one, the only thing that I want to show is this base module. So what I can do is, instead of doing the whole thing, what I'll do is I'll ungroup this, and then we're gonna just get rid of everything that has to do with that second volume. And this gets a little bit confusing here. So you can start to water down the amount of lines that you actually have here, so that you can only see certain portions of it. Another thing you can do is if this part of it gets really confusing, we can say let's just delete that. And then instead of doing that, let's go back to our original axo here, and we can just choose those pieces. And then if we do another make 2D here, what that will allow us to do is we can group this. And then let's do that again for this piece, and we'll do a make 2D here. And we can group this. And by doing that, we've broken out our two pieces. So by actually keeping the 3D information here, you allow yourself a lot more flexibility. And now the reason that I'm actually going in and doing that is one of these I'm using to show this volume. So I'm going to move that back there. And then we can actually delete this. And then for this one, really what I'm showing is this volume. So I can move that to there and delete this guy. And then that'll get rid of a good amount of information there that you don't actually need. So then what I wanted to do is, my base massing model is here. Then I show more detail as I'm getting into the planarization of this first volume. I explode out a volume here, and then I can do the same process here. So if I move this over to here, then I can project that up like that. Again, drawing out my explosion lines here. So I would look something like that. And then you would continue doing the same exact thing for adding your floor plate under there. And then you would continue adding all of your walls and pieces into here. So that's the basic construction of them. You can, obviously there's no right or wrong way to do this. What you want to keep in mind basically is this organization of your different lines. Keep all of these things grouped, keep them all on separate layers, allow yourself the most flexibility that you possibly can so that you can add or delete things pretty much at will. So what we're going to look at here is one last thing that's just going to talk about scale. So how do we know that this axo actually worked? So if we go to one of our pieces, let's go here, and we type distance. This line should actually represent the thickness that we made all of our walls. So if we do distance here, we can see that it is indeed 1 foot. So you can do a test on a couple of different pieces here just to make sure that they're all at the right scale, and they look like there are. So the thing about an axo is that all of your dimensions should be true dimensions. So check anything that's an orthographic dimension, and that should be correct. The last thing is, how do we know what scale this is going to be when we either go to print it, or if we bring it into AutoCAD, or if we bring it into AutoCAD and then Illustrator? So what I like to do here is actually draw a rectangle that is going to register the 8.5 by 11 piece of paper that you're actually going to be putting this on. So 11 inches tall, and this is going to look really tiny, and then 8.5 inches wide. Okay, so that's going to register my little 8.5 by 11 piece of paper. Now, what I wouldn't recommend doing is scaling this down into that piece of paper, but we can think about this piece of paper at a larger scale. So if we think about this, this is 1-to-1 to my actual piece of paper. But what if I scale this up by 12? So if I type scale, then click that, and then type 12. So this piece of paper is now basically registering what this drawing would look like at 1 inch equals a foot. And the reason that is because we've scaled it up from 1 inch at scale to 1 foot by multiplying it by 12. Now, if we look at trying to figure out what scale we can actually make this at, from here, it's fairly easy. So we can scale this up. So if we just type scale, we can look at actually making this. So let's say we scale this up by 2. So that would then be at 6 inch. So that would be at ½ inch equals a foot. If we scale it up again by 2, it would be at 1/4 inch equals a foot. 1/8 inch equals a foot. Scale it by 2 again would be at 1/16 of an inch equals a foot. And then we can see if it would look, if we scale it again, we're going to be looking at 1/32 of an inch equals a foot scale roughly. And so now if we want to check this and check our math here, what we can do is we can draw a line that registers 1 foot long. And then if we scale this, so type scale, and if we go from this corner to that corner, and then we type 1/32 of an inch. So now when we do a distance here, we should be back at 0.71 feet, which if we convert 0.71 feet, that should be 8.5 inches. So if we did 8.5 divided by 12, that would be 0.71 feet. So we can see that we're actually at the right scale here. So basically what I'm telling you here is that you're looking at probably having your model at 1/32 of an inch equals a foot, depending on what type of organization you're doing. And then try to fill out that page pretty well. So I wouldn't go at a weird scale in between 16th and 32nd. I would keep it probably at 16th or 32nd or 64th, depending on what you're working with. So from here, you're going to then export this into the program of your choice, or you can plot straight from Rhino, adding a couple of different graphic properties. I will be posting more examples of what a drawing like this could end up looking like. I'm going to take the same base drawing and then add different effects to it to show how they could end up looking. I've also included on our Miro board, obviously a bunch of different pieces of inspiration, but feel free to look at your precedent boards for different ways of, not just Axos, but different ways of coloring drawings and things like that. And look out for more tutorials on how to incorporate graphic scales. I'm going to be adding a bunch of Illustrator and Rhino and AutoCAD tutorials about graphics in the coming weeks before this assignment is due. So please take a look at those and start to incorporate those into your drawings as well. I've once again brought these 2 tutorials to the forefront, how to basically import at a scale. So once you have this drawing all set up in Rhino or in AutoCAD, you can then import it into Illustrator if you'd like, and these 2 should help you actually to import that at scale. The last thing about this little method of actually scaling the 8.5 by 11 piece of paper is that this is a really good way of double checking that your scaling worked once you go into Illustrator, because this page will actually fit perfectly the boundary of the 8.5 by 11, so you can be sure that you're at the correct scale. So keep an eye out for those other tutorials, and in the meantime, let me know if you need any assistance with this. Keep in mind that there is really no right answer. This is basically a shuffling around process to see how clearly you can make this drawing register a certain assembly process and a certain graphic style.